evening, folks. If anyone else is still logging in, we will just let them join when they get here. We are SECRES. That's the Southeastern Colorado Renewable Energy Society. I'm Brent Kennedy. I'm chair of SECRES. I'm here, and welcome to our webinar tonight, Building Efficiency Basics, Selecting Appliances. SECRES is the Southeastern chapter of the statewide CRES, Colorado Renewable Energy Society. We are a nonprofit organization staffed entirely by volunteers. Our mission is to educate the public and promote the use of clean, healthy, and low-cost renewable energy and energy efficiency. Get more information about that at cres-energy.org. And once there, you select chapters and the SECRES button to find more information about SECRES specifically. And just a note right now that we are always looking for board members. So if anyone is interested, drop us a note and we would invite you to a board meeting and get to know you and see whether it's a good fit. All right, as far as the presentation, Energy Efficiency Basics, tonight's virtual event will discuss techniques for choosing efficient appliances and electronics and the potential savings involved. Residential and commercial buildings in the U.S. consume 20 quadrillion BTUs of energy each year, representing a full 40% of the nation's total energy consumption. A growing percentage of this consumption comes from plug loads, that is, appliances and consumer electronics. Using efficient appliances and eliminating phantom loads offer cost-effective means to save money and reduce one's carbon footprint. Our presenter tonight is Derek Law. He's also a board member with the Southeastern Colorado CRES chapter. Derek and his family moved to Colorado Springs in July of 2020. Recently transferred to the Space Force after serving 18 years in the Air Force. While on assignment with the National Reconnaissance Office, he chaired the Sustainability Committee's Energy Board and led efforts that reduced the power consumption of a large data facility here in Colorado. Derek has a background in electrical and systems engineering and was awarded outstanding thesis from the Naval Postgraduate School for an approach to optimize solar and wind energy systems in Afghanistan. His home is now solar powered. He drives a Chevy Volt, received a home energy audit, and followed up by adding insulation to his house. Founding member of the 2021 Colorado Springs Solar United Neighbors Co-op, served on its vendor selection committee, and is currently a board member with SECRES. And without further ado, I'm going to turn this over to Derek.
All right, thanks, Brent. Yeah, appreciate it. Thanks for the introduction. And thanks for all the attendees for taking the time to listen to the presentation. Hope you find the information helpful. I know that me giving the lecture has been helpful. I did this last year, and doing this again now keeps me disciplined on making sure that I'm doing the right things as I go along, and I'm doing some home improvements myself still. We did a kitchen upgrade recently, and now I'm in the process of buying a heat pump. So we won't get into heat pumps in this lecture, but it's been helpful overall in making the smart decisions to reduce energy consumption. So first, let's start by looking at the overall picture of how total energy in all forms is consumed throughout the U.S. The U.S. Energy Information Administration breaks down for us this information into 4 different sectors: industrial, transportation, residential, and commercial. Industrial consumes 34% of the overall energy picture, transportation 26%, residential 22%, and commercial 18%. So the residential sector alone consumes 20 quadrillion BTUs, or British thermal units of energy. That number is kind of unfathomable for me anyway. 1 quadrillion is 1,000 trillion, and 1 trillion is 1 million million. So we're talking about a lot of energy. So now let's look at the sources from which the just the residential sector alone consumes energy. Okay, so there's 5 categories: natural gas, electricity, petroleum, renewable energy, and coal, with the 2 highest sources being natural gas and electricity, competing for number 1. We're at about 5 quadrillion BTUs for electricity consumed now. This doesn't even account for the 9 quadrillion BTUs that are lost in the energy production and transmission. And while the natural gas seems to have plateaued since the early 70s, electricity still continues to climb since inception. However, you can see that electricity's rate of increase has decelerated the last few decades. In part, the deceleration is due to the advent of more efficient appliances overall, and especially the efforts from the Energy Star program, which has been advocating and promoting the most efficient appliances on the market. This program has been saving roughly 500 billion kilowatt hours of electricity annually, and roughly 390 tons of greenhouse gases, which is equivalent to about 5% of US's overall greenhouse gas emissions. So since 1992, Energy Star and its partners helped American families and businesses save 5 trillion kilowatt hours of electricity and avoid more than 450 billion in energy costs and achieve 4 billion metric tons of greenhouse gas emissions. I should say reduction in greenhouse gas emissions. So now let's look at it by the home. So what typical home's energy consumption from all sources, which includes gas and electric. Looking at it this way, we can see that the biggest offender, of course, is heating. Second biggest offender is called the all other category. This category is made of plug loads, thing you would plug into your outlets, and appliances of all types, except refrigeration, which has its own category. We'll spend the majority of the time talking about this all other category in this presentation. Since furnaces and other heating solutions like heat pumps can easily have their own dedicated lecture. So look for those across CRES as we're going forward. I think you may see those lectures in the future. But I will say the biggest thing you can do without buying a new heating solution is just to add insulation to your attic and do your best to seal your home, the home envelope around doors and windows. If you have the opportunity to build your own home from scratch, then heating is definitely the category you want to focus on first. Now, here's a view of the loads from a home that was built with net zero as a goal. So when you maximize the efficiency of your home envelope and utilize passive solar heating, like with a passive solar wall, then you can see now that appliances and plug loads now become the biggest draws of power in your house. So now we can look at just the electrical loads by appliance. So it's probably no surprise that air conditioning comes at the top of the list, along with heating, both water and air. So let's say you're not in a position to build your own net zero home, then here, highlighted in yellow, are the areas we can look to cut energy use. Note the size of the bottom category for all other miscellaneous. Those are the plug-in loads. And those highlighted categories from the last chart are shown here. And this is what is known as like the low-hanging fruit of residential energy sustainability world, because these are the areas where we have the greatest control over and have the easiest fixes for. So efforts focused in these areas will have the greatest return on your investment in terms of dollars spent, especially considering the rebates that are available from your local utility, whether you're CSU or other in Colorado. A lot of them offer various rebates. And then also return on investment in terms of reducing your overall carbon footprint. All right, so we're going to start off with lighting. So this is by far the easiest category to address and has the highest return on investment. Being in the military, I've had to move a lot over the years, and one of the first things I do, literally within the first week of living somewhere, is go around and take out all the incandescent light bulbs, replace every single one with an LED bulb. And here's why. Incandescent bulbs are basically heaters. They produce a little bit of light. So 95% of the energy they consume is converted to heat. So you're only producing 16 lumens of light for every watt of electricity, and you're making your air conditioner work that much harder in the summer. So compare that with compact fluorescents, or CFLs. Those came out in the 1970s in response to the 73 oil crisis. And CFLs put out 60 lumens of light for every watt of electricity. It was an improvement in efficiency over incandescents, but they're prone to flicker. They contain a toxic mercury, and you have to dispose of those through an approved waste management stream. But now let's introduce LED, which became widely available around 2010. And an Energy Star rated LED can produce up to 145 lumens per watt. So this is pretty significant, considering lighting consumes over 10% of a home's electricity budget. So even factoring in that an LED bulb will cost you more initially than an incandescent bulb, you'll spend way more in bulb costs just replacing that same incandescent bulb over a 10-year span. In addition, most LEDs are now dimmable and have different visible light spectrum options like daylight or soft white and other options in between. And if you wanted to get really creative, you can get a color changing light bulb as well. And as a bonus, you don't have to throw away those LEDs in a special waste stream. They don't have any special handling like the CFLs. I do recommend, however, that you get a good brand, because not all LEDs are created equal. You can find some that may disappoint you, especially if you get the cheapest ones you can find on Amazon. I learned that the hard way. Now I just buy Philips, but there are other good ones out there like CRES. And then I'm going to show you how you can use the page on the next slide. It's the energy.gov site to help you find the best LEDs. And I'll basically show you that how that works by demonstrating it with refrigerators. So that's our next category. So see the link at the top of the screen, energystar.gov. They did all the work for you. So you can quickly and easily sort to find energy efficiency appliances like refrigerators, light bulbs, whatever, many other appliances. It's very user-friendly, tons of options to filter to fit your budget, size, features. And to get an Energy Star rating, each appliance has its own metrics that has to meet certain thresholds. And Energy Star refrigerators, for instance, needs to be at least 15% more efficient than models that meet the minimum federal efficiency standard. So a standard set for each size and configuration. So generally speaking, smaller capacity refrigerators are going to consume less energy than larger ones, and freezer on top refrigerators, those are going to be more efficient than the freezer on the bottom. But if you want to make your decision purely on lowest energy consumption regardless of type, you can download the standards for every type of configuration and then just make your own decision from there. And if you still want that freezer on the bottom, you could aim for those that meet the most efficient criteria for refrigerators, which is at least 27% more efficient than the federal requirements. That's a new criteria that they added. So if you see on this page, the first Energy Star, the blue Energy Star box on the right, is their standard certification. But if you go down, you'll see the new one that says most efficient in 2022. Now they've got the 2023s out, but that'll help you pick the most efficient in their category. So to contrast today's technology with that of the 80s, see that note on the bottom left part of the chart. It shows you that the total energy consumption of a refrigerator in the 80s was about 1,200 kilowatt hours. That's more than double what they are today. No wonder why utility companies, currently at least CSU, gives you a $50 rebate simply for recycling your old refrigerator, and they'll come and get it for you, and it gets it off the grid. So another interesting point to note at the bottom of the chart is that if you put a refrigerator in an unheated garage in the winter, you're going to lose 15% efficiency. This is due to the automatic defrost sensor that's detecting that the refrigerator section is getting below freezing. So your garage is getting so cold that that section is now automatically kicking off the defrost mode more frequently than it would in a heated room. So it's not always good to have extra refrigerators and then furthermore to keep them in the garage. Next category, we're going to talk about clothes washers. We have an energy metric called Integrated Modified Energy Factor, or IMEF, and a water consumption metric called Integrated Water Factor, or IWF. So with respect to the energy factor, IMEF, it's intended to roll up 5 sub-metrics: the capacity of the washer, the electricity used by the washer, the hot water energy consumption, and the energy used to run the dryer. In other words, how well does it wring out the water? So that'll benefit the dryer. In combination, that combined with the low power mode energy consumption, which is L. So the higher the IMEF, then the more energy efficient the washer. With respect to the integrated water factor, the bottom half of the screen, it simply accounts for the water consumed and divides that by the capacity of the washer. Since the capacity is now in the denominator, a lower IWF is more efficient in this case. So now when you're sorting and filtering your searches for washers, you'll understand these metrics that show up next to each washer. I also recommend you start your search with front load selected as the load configuration filter. They're far more efficient with respect to both energy use and water use. And then again, those front load washers make stacking possible. You can use pedestals, you can put storage underneath, and you can't do those with the top loading washers. Clothes dryers. Now these are the biggest energy offenders when it comes to the plug-in home appliances. Energy Star didn't even have a category prior to 2014. They use a combined energy factor that basically accounts for the load size and energy consumed while operating and during standby cycles. So higher CEF, the more efficient. It is important though to select a dryer that meets your family's load sizes, because a too large of a capacity just wastes energy. So does a too small of a capacity, because then you're doing multiple cycles. And there's 3 basic types of dryer configurations. You get traditional vented, which most people have, require you to have a large hole in your house, creating a vacuum of about 300 to 350 cubic feet per minute. And then the other type is a ventless, which uses a closed loop system with an internal condenser to remove the evaporated moisture from the heated air. The moisture is removed and collected in a reservoir and drained out through a tube. Now, there's a heat pump configuration that solely uses heat pump technology to dry clothes. It heats, dehumidifies, and then circulates the air in the dryer drum. So no vent is even required with the heat pump configuration. The ventless heat pump, combination of those two, is the most efficient type of the dryer you can get. You can see that even within Energy Star's rated models, there can be quite a range of power consumed, with the most efficient being around 299 kilowatts per year, and the least Energy Star efficient model coming in at around 640 kilowatt hours per year. So note the price difference for this can be significant as well. Almost $40 difference per year. For comparison, a non-Energy Star dryer can use as much as 900 kilowatts per year. And this is one I have the standard dryer, and I wish I would have learned this sooner. Otherwise, I'd be using the heat pump ventless mode. So that'll be our next purchase. So here's an example of a search for the most efficient dryer, and you can see that again the ventless heat pump comes out right on the top of the list. We'll talk about dishwashers. So dishwasher technology really improved over the last decade, and new Energy Star certified dishwasher uses less than a quarter of the energy used when washing dishes by hand, and saves more than 8,000 gallons of water each year. So by reducing water consumption, Energy Star certified dishwashers also help protect lakes, streams, and oceans. They also boost water temperatures to 140 degrees, which improves disinfection compared to hand washing. Energy Star consumption factors in both the energy to run the appliance and then the energy used to heat the water, as well as the total amount of water used. So first, decide the right size, like your washer, and then like your clothes washer. And so you can either get a compact, you can get a standard, and then make sure it has an auto sensing cycle. So that means that the dishwasher has a soil sensor and is able to detect if the water is coming out, the water coming off the dishes is either dirty or clean, and that can save water and help ensure that the dishes come out clean as well. And then look for other energy saving options like the ability to turn off heated dry, and then finally break it down by energy use and water use. Now we'll consider other miscellaneous consumer electronics, which is the category having the fastest growth, and we'll discuss phantom loads. First, when you're shopping and you're not looking at the Energy Star website, you can still see that many consumer devices have the Energy Star label, so always go with those. Then set those devices up in power saving modes. It can be done for computers, monitors, printers, modems, routers. It's better to turn the device off altogether rather than use the standby mode if you can, because some of these devices still consume energy when not in use. So meaning if they're in the off position or standby mode, they still consume energy, and we call that the phantom load. You might have heard it as a vampire load or ghost energy. In addition, like all transformers, those AC to DC converters, those black boxes we plug into our outlets, they inherently draw phantom loads unless they're unplugged from the wall. So cable and satellite boxes, they're known to be one of the biggest offenders. It's because satellite boxes continue to receive the satellite data for tracking purposes even when they're off. To discover other offenders in your house, you could buy a kilowatt meter. That's what it's called, kilowatt. Or you can check it out from Pikes Peak Library. They have them for rent. And then the meters simply plug in line with the device you're trying to test, and they'll provide you an energy reading, and then you can see how much is being consumed when the device is off. And then you can also dedicate power strips to those devices, and then to shut down the power strip. That way you're disconnecting them without having to unplug each one. And then you can even add to that, you can put on an automatic timer onto the power strip. Then you don't have to worry about remembering to shut it off. But just don't exceed the timer's rated value, because some of those timers, the digital ones, have a limited number of watts or amps that they can pull through. So just pay attention to that. Here's some real world data points from a home energy auditor. And it really makes the case to get after the phantom load problem. So these are examples of electronics that are powered off or in standby mode. And the only exception is the garage fridge at the bottom. That wasn't turned off, it was just empty. So it didn't need to be plugged in. But as you can see from these examples, the cumulative impact would be about $20 a month. So, show you that our homes could easily reflect this same accumulation of energy vampires if left unchecked. So here's some additional energy-wise considerations. We first moved here in 2020, and our house had a gas cooktop, and we never had that feature before, so we thought it'd be much better than electric, but it really wasn't. We smelled gas leaking in from one of our valves, and had to get a special valve ordered and installed. So during our kitchen remodel process, we just decided we're going to make the leap, get the induction stovetop. Now we can boil water faster than our convection or our previous convection or gas ranges. So it's way better process. You can control it with your phones. You can instantly adjust the heating level. So if you turn it up too high, you can bring it right back down again. And you can even get an induction capable pressure cooker. So that further reduces the cooking time and energy required. Another miscellaneous fact is that a lot of new electric vehicle chargers have Energy Star ratings. So for further reading on other Energy Star tips at your home, check out that energy.gov Energy Saver Appliances Electronics page. I have the link there. And we talked earlier about measuring plug-in loads at the outlet, but also consider getting a home energy monitor. So this monitors the whole house. Your utility company may have put on a smart meter, maybe even one that gets down to the hour-to-hour consumption. So see if you have that first, but also consider getting one that connects to the circuit panel so you can read the energy consumed in real time and can isolate the loads by circuit. Another benefit is that you can see if there's any hardwired devices that you couldn't measure with an outlet meter. And then I'd recommend getting a monitor that uses machine learning, and then it'll identify and attribute specific power spikes to specific equipment in your house, help you take the guesswork out of trying to determine which devices are the biggest offenders. Rebates. So I mentioned earlier that rebates were available to help quicken your return on investment. Now, and for a lot of these, low-hanging fruit. So on the left-hand side of the chart, you can see that Colorado Springs Utilities complete rebate offerings. So you just go to their website and you can see what all they offer there. And it's a very painless process. You put your basic contact information at the top, identify the device you purchase, upload the receipt, copy your license, and then your name and signature on the signature block, and then you just click submit. So the bottom of this chart, you can see how it shows up on your utility bill. There's the one I got from my dryer. And on the right side, here's an example of all the cumulative rebates that I've taken advantage of just since I moved in. The dryer, the smart thermostat, a rain sensor, and a Wi-Fi controller for the sprinkler, insulation for the attic, the solar panels, and that $580 for the solar panel rebate was just from CSU. That didn't include the 26% federal credit for my solar panels. So I just want to show you what money's out there to help you make the transition to smarter appliances. And lastly, realize you may not be able to read all the details on here. It might be kind of small from your view, but I provided a link at the top. That's a great resource for all the rebates out there, especially if your energy company isn't CSU. These are all the other ones in Colorado area. So that concludes the formal portion of the presentation. We can go ahead and stop the recording now, and we can bring up some of the questions that you folks have presented. And if I can't answer them, I'm open to other members sharing their knowledge as well.